Okay, for example number 1, it just literally gives you guys a list of data values. Now, it doesn't specifically ask you to draw a box and whisker plot, just as talking about a number line, but I'm going to go ahead and just do the box and whisker so it's there and you guys have an example of it. So number 1 says write the data in increasing order. So if you give me a second, I'm going to pause the video and I'm going to do that. Okay, so I got all my data values there, and again, guys, it's always good to double check and make sure that the number you have listed is equal to the number that's in the example. So the example has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay, so I must have gotten them all. So now it says find the first, second, and third quartile. So it wants us to find Q1, Q2, which is just the median, and Q3. So I always think it's easiest to start with the median first. So find your middle value of your data. So if we have 12 data values, it's not going to fall on one number perfectly. So let's see, 1, 2, 3, 4, 5, 6. It's going to be in between 12 and 16. So whatever that number is between those numbers is going to split our data in half. So Q2 is going to be whatever 12 plus 16 divided by 2 is. So 12 plus 16 is 28. And 28 divided by 2 is 14. So that's our Q3, or our Q2. Okay, now our Q1, our lower quartile, is the median of our lower half of data. So that's going to be 5, 7, 9, 11, 11, and 12. So we have 6 values because half of 12 is 6. So we have to find the median of these data values. So it's going to be in between 9 and 11. So what is in between 9 and 11? Well, 10. But 9 plus 11 is 20. 20 divided by 2 is 10. And Q3, what would be the median of our upper half of data? So 16, 17, 19, 25, 28, and 44. We need to know what is in between 19 and 25. So 19 plus 25 divided by 2. Our Q3 is going to be 22. I'm going to get 44 divided by 2 is 22. So now we have all 3 of our quartile values. So now it says, draw a number line that includes the least number and the greatest number in the data set. So what that means, guys, is you just have to make sure that when your number line, it includes all your data values. So if your lowest data value is 5, you can't start your number line at 10. And if your number line ends at 44, you can't stop your number line at 36. It has to include every value. So I'm going to pause it again. And I'm going to try to do somewhat of a neat number line here for you guys. And as I pause it, you guys can pause it too if you like. But I will have it here for you in a second. Alright guys, I choose to go by 3s. But it doesn't really matter what you guys choose to go by, as long as it works for you and it fits all your numbers on there. So, first thing I do is draw my box. So the box is going to be made up of your 3 quartiles. So the first line will be Q1, second line will be your second quartile, and the third line will be your third quartile. So our quartile 1 is at 10. So that's going to be right around or close to there. in between 9 and 11.5. Okay, and then our second quartile is at 14. So that's going to be around there, just before 15. And our last quartile, which is 3, is going to be at 22, which is going to be right around there. So then I just draw my box. And then your dots are your two extremes. So what is our lowest value and our highest value? So our lowest value is going to be at 5. So that would be your whisker. And at 44. So there's your box and your whiskers. So what happens here is 25% of your data is in between each of these sections. So if there are 12 kids, say those were number of basketball shots that they scored. If there are 12 students, 25% or a quarter of 12 would be 3. So that means that 3 students scored between 5 and 10 shots. Or in between 10 and 14, or in between 14 and 22, or 3 of them scored between 22 and 45. So each one of those sections is 25% of the population or of your data. So number 4, then it asks us, are there any outliers? If so, what are they? So again, your outlier formula is up there at the top. So we need to check first, does anything lie outside of our first quartile, which is 10 minus 1.5 times our IQR. Well, we have to find out what our IQR is. And again, IQR is Q3 minus Q1. So IQR equals 22 minus 10, which is 12. So 1.5 times 12. So you can put that into your calculator, and you get 8. So if there's something below, -8. If there's something below -8, that would be an outlier. But the lowest value we have is 5. So there's no outliers on the lower extreme or on the lower portion of our data. But let's also check our upper extreme or our upper set of data. So now we have to add the 1.5 times our IQR. So our Q3, our third quartile, which is 22, plus 1.5 times 12. When you put that into your calculator, you get 40. 44 does lie beyond that value. So 44 is an outlier.